Hi, I'm Becky Stern, and today we're exploring sound-reactive electronics, projects that can sense and respond to sound. Keep watching to learn all the ways to sense audio, from basic vibration to voice recognition, so that you can pick the right path for your project. Let's get started. If you've been following along with this series, you've learned how to work with basic inputs and sensors from our Arduino input-output episode. If you're new, check out those earlier episodes to strengthen your foundational skills and build your first circuit. Audio sensors are just another kind of input. Once you can read its data, you can make lights flash, motors spin, or trigger other creative effects in real time. The first component I want to show you is a piezo element. When it's wired up basically like this, we often call it a contact mic because it can measure vibration by being directly in contact with an object. The most fun project example I can think of to show you is the Secret Knock gumball machine. It takes a special sequence of taps to unlock the candy, where the sensor is a piezo attached to the underside. The Arduino code is reading the piezo signal through an analog input pin. This makes it easy to adjust the threshold for how hard you have to knock, which this project does with a potentiometer. And yes, piezos are the same thing that's inside those little buzzers too. Because not only do they turn vibration into electrical flow, they also do the opposite. So it's possible to vibrate them by driving them as outputs. The next category of components I want to introduce you to is microphones, which capture sound vibrations from the air, not just mechanical vibrations through direct contact. There's a diaphragm that influences the electrical flow through a coil of wire in proportion to the sound waves it encounters. There are two different kinds of readings to play with: amplitude and frequency. Amplitude is the loudness of a sound. That's how big the pressure wave is. This is what simple microphones measure by default. You might use amplitude to fade LEDs brighter when a sound gets louder, or trigger a motor when a sound passes a certain volume threshold. I've made a couple of wearable LED projects using little microphone plus amplifier breakout boards, and they always make people smile. The code for these two projects provides a good example of normalization, where the program samples the volume multiple times, then dynamically adjusts the animation so it looks good in both quiet and loud environments. Shout out to Phil B, who wrote this excellent Arduino code. Frequency is the pitch, how high or low the sound is. To work with frequency data, you'll need to either process the audio signal in software or use a chip that handles it on board for you. Converting the signal from the time domain to the frequency domain requires the most important algorithm of all time, the fast Fourier transform. It's not easy math, and digital signal processing is a complex field. But for the purposes of this guide, all you need to know is that frequency detection usually involves dividing the audio spectrum into different bands or buckets. So when you see a graphic equalizer, you're seeing the lights in each column in proportion to that band of frequencies. You can use a basic electret microphone for your project wired to your microcontroller's analog input for sensing the presence and volume of sound. But if you want to measure frequency and don't want to do your own DSP, there's an inexpensive chip that can do the heavy lifting. It's the MSG EQ7 graphic equalizer chip, and it splits an audio signal into 7 frequency bands and gives you a value for each, which you can then use to make an LED animation. Another fun way to make your project react to sound is through voice and speech recognition, which is easier to accomplish these days than it ever has been before. DF Robot makes a really cool standalone speech recognition board. Instead of just measuring loudness or pitch, this board recognizes specific spoken words. That's perfect for voice command controlled projects, like Kiara's workshop Animatronic Pikachu.
Get some rest.
He's a sleepy boy. It's really cool. Another way to do voice recognition is through a single board computer like a Raspberry Pi with a USB microphone plugged in. This can be handy for adding voice commands to your home automation system or monitoring your home for specific sounds like glass shattering. And there you have it, a beginner's guide to audio reactivity. DigiKey offers several inspirational and informative project guides you should check out if you're interested in making a project that reacts to sound. One is Clive Maxfield's audio-reactive artifact, in which NeoPixels are used to visualize the output of an MSG EQ7 graphic equalizer chip. Sean Himmel made a guide on how to create a custom wake word for the Mycroft AI voice assistant. And Sean and Ajay worked together on the AI voice interactivity of Digit, one of Jay's latest companion robots. And every week on the Maker Update here on the DigiKey YouTube channel, you can catch up on what cool projects folks are making around the web, including some impressive sound-reactive projects like Aaron St. Blaine's LED top hat and Pyrograph's audio spectrum display, both of which have great tutorials if you want to follow along. So check out the links to all the projects I mentioned in the description. And don't forget, you can share your own builds with the community on DigiKey's Maker.io. We'd love to see what you're working on. I hope this video gives you the confidence to start using these techniques in your own projects. In a future episode, we'll cover audio output options from sound playback to musical microcontrollers. Leave your advice and questions in the comments so we can all learn together. Check out the playlist with the rest of the series and subscribe to be sure you don't miss the next one.